Good morning, everybody. I am Reshma Kailas user, and today I am going to teach you fundamentals of operating system. Okay, so let us begin with an introduction. Okay. So first of all, we will see the major types of software. And that as all of you know that the major type of softwares are application software, system software, and obviously the basic component is the hardware. Okay, and user is basically interacting with the application softwares. Okay, application software using some system software to perform the execution of the application which is intended by the users. Okay, so some of the application softwares application softwares can be developed using languages like assembly language, Fortran, Basic, Pascal, C, etc. Okay, and what are the examples of application software? For example, banking system, airway system, hospital management system, library management system. These are some examples of application softwares. Okay, and what are the system software? For example, operating system is one of the system software. Okay, which schedules computer events, allocates computer resources, and monitor events. These are some fundamental tasks of operating systems. Okay, and other examples of system software are language translators, for example, interpreters, compilers, assemblers. Okay, and other than this, utility programs. Now, utility programs contain some routine operations. Okay, which are performed by the users again and again. Okay, so for example, sorting, listing, printing. Okay, managing data, creating files, merge files. Apart from this, the antivirus softwares. These are also the examples of utility programs. Okay. Now let us see the components of computer system programming. The hierarchy begins with a physical machine. Then system softwares are there. In that, system software contains operating system, language processor, loaders, linkers, and text editors. Right. Then language processors again having parts in that the translator, the major components are translators, compilers, interpreters, assemblers, and microprocessors. Okay, I think these things we have already seen in the system programming as well. Okay, let us begin with the introduction of operating system. Now, basically what is operating system? Operating system is plays the important role between hardware components and the user. It plays the interaction between the user and the hardware. Okay, so OS or operating system functions can be classified into resource allocation and related functions and user interface functions. Okay, so an operating system is an interface between user and the computer hardware, and basically it provides a convenience, efficiency, resource allocator, and control program to the users. Okay, here are some functions in that. The resource management is the main important functions which is provided by the operating system. Okay, in that it performs the some common task, that is CPU. CPU performs the process management. Process management contains the scheduling algorithms. Okay, we will see in the further slides what are scheduling algorithms. Okay, then the memory is there. Memory, how many memory allocated to process the some particular task. Okay, then input output devices. Okay, and after that the storage management. Obviously the storage management is related to your main memory. Okay, and then the secondary memory management and file management is also this functionality is also provided by the operating systems. Okay, let us move towards the next slide. Here are some operating system services. Okay, in that the very first one is the program execution. Then there is input output operations. Then file system manipulations. Okay, then there is a communication, error detection, resource allocation, and protection. Okay, so these are some services which are provided by the operating systems. Okay, let us move towards the next slide. Now here are some different types of operating systems. Okay, nowadays we are using a multi-programming operating system as well as time sharing, multitasking, distributed operating system, network operating system, and real-time operating system. Batch operating system we are not using nowadays. Okay, so these are some different types of operating systems. Okay, let us move towards the next slide. Now, operating system structures basically having four types. Okay, in that the very first one is the simple and monolithic architecture. Then there is a layered architecture. After that, there is a micro level architecture and the hybrid architecture. Okay, let us move towards the next slide. Now, come to the part of process management. Now, very first of all, we will see what is process. Okay, in that we will see the process concept first of all, then process scheduling and operations on the processes. Okay, so process means what? See, a process is a program which is in execution is called as a process. Okay, so process is basically defined by five tuples. Okay, in that the very first one is the process ID, then there is a code, then there is a data, register values, and PC values. Okay, now here the process ID is unique in the system. Okay, code is the program code. So let us move towards the next slide. Okay, so process concepts, as I already told you, process is a program in execution. Okay, so basically, see what is the difference between program and process is that a program is a static entity, whereas a process is a dynamic in nature. Okay, because it represents the execution of a program. Okay, so it is a dynamic in nature. So process is a active entity. Okay, a process includes text section, program counter, stack, data section, and heap. Okay, here is a diagram which shows how process in main memory is uh, denoted. Okay, so here you can see uh, whatever the sections we have already seen, the same sections is shown here in the memory. In that, the stack, then uh, just a second. Okay, then heap is there, data section, and the text section. Okay, let us move towards the next slide. Now, next section is the process control block. Now, process control block means what? Basically, it stores data needed for correct and efficient process management. Okay, and see, a process is more than simply a program in execution, right? So, an operating system considers our process to be the fundamental unit for resource allocation, and some resources could be allocated to a process. For example, memory, secondary memory, then I/O devices, files opened by the process, CPU time consumed by the process. Okay, a data structure called the process control block is used by an operating system to keep track of all information concerning a process. Okay, so the process control block of process contains the information like process ID, process state, then program counter, CPU register, then CPU scheduling information, memory management information, accounting information, Okay, in that amount of CPU used for process execution, time limits, execution ID, input output state and information. So all this part is contained in process control block. Okay, let us move towards the next slide. Okay, here is a figure which indicates how process control block is denoted. Okay, the same things, same information is denoted in the block. Okay, here is the process state. The process state includes new, ready, running, waiting, and terminated. Okay, so here basically the process state is used by an operating system to simplify process scheduling. Okay. So a process, suppose for example, a process Pi is said to be in a state Si if Si is an appropriate description of Pi's activity. Okay, so the four fundamental states, that is running. Running means what? A CPU is currently allocated to the process and the process is in execution. Okay, then the next is the suppose waiting. Okay, then waiting means what? The process is waiting for some event to occur. Okay, then terminated, the process has finished its execution. Okay, and ready means the process is not running, however it can execute if a CPU is allocated to it. Okay, and the new is the process is being created. Here is a diagram which states it 5 process state model. Okay, the status is new. First of all, process is created, then it is goes to the ready queue. After that, it goes to the running queue. If there is an input output or event wait, then it goes to the waiting state. After scheduler dispatch, again it goes to the ready state. Okay, and after ready state, again it goes to running state. Here you can see, and if there are no more what we can say interrupts, then it goes to the terminated state after completing it. Okay, let us move towards the next slide. Here is a 7-state model of process. Okay, now here you can see the CPU switch from process to process. Okay, so you can see here the process control block is used to save the state of previous state and moves the control of CPU to the next process. Okay, this figure is clearly denotes the same thing. Now let us begin with the thread. So thread means what and what is the need of thread? Thread is a basic unit of CPU utilization. Okay, and a thread is a flow of execution through the process code with its own through its with its own program counter, system registers and stack. Okay, basically threads are a low cost alternative to processes for certain kinds of concurrent applications. Okay, there are two sets of reasons for high overheads of switching between processes. There are two reasons. The first is the intrinsic reason and the OS related reason. Now, intrinsic reasons means what? These reasons actually follows from the definition of process. A process is defined as an execution of program. Hence, while switching between processes, the execution context of a running process has to be saved and that of new process has to be loaded. And OS related reasons, these reasons follow from the way the process abstraction is implemented in an operating system. Okay, and let us move towards the next slide. This figure indicates how single-threaded process and multi-threaded process works. Okay, in a memory. Okay, now this first one denotes the single-threaded process, and this second one is the multi-threaded process. Here are some examples. A web browser might have one thread for display images or text, while another thread retrieves data from the network. Okay. The next example is a word processor may have a thread for displaying graphics, another thread for responding to keystrokes from the user, and a third thread for performing spelling and grammar checking in the background. Okay. And the third example is a busy web server may have several clients concurrently accessing it. Let us move towards the next slide. Here is the difference between process and threads. See, process is a heavyweight or resource intensive. Okay, thread is a lightweight, taking lesser resources than a process. Okay. Process switching needs interaction with operating system. Okay, thread switching does not need to interact with operating system. Okay, in multiple processing environment, each process executes the same code but has its own memory and file resources. Okay, in case of thread, all threads can share same set of open files, child processes. Okay. In case of process, if one process is blocked, then no other process can execute until the first process is unblocked. In case of thread, while one thread is blocked and waiting, second thread in the same task can run. Okay. In case of process, multiple processes without using threads use more resources. Okay. In case of threads, multiple threaded processes use fewer resources. Now, in case of process, the last point is in multiple processes, each process operates independently of the others. And in case of threads, one thread can read, write, or change another thread's data. Okay, so this is the difference between process and threads. Let us move towards the next slide. Here are some advantages of threads. Thread minimizes context switching time. Use of threads provides concurrency within a process, efficient communication, okay, economy. It is more economical to create and context switch threads. Utilization of multiprocessor architectures to a greater scale and efficiency. Okay. Here are some disadvantages. Blocking of parent threads will stop all child threads. Okay. Multi-threading model. Okay, so basically multi-threading model contains the user level threads and the kernel level threads. Okay, now kernel level threads, the user level threads. In user level threads, a process does not create threads using a create thread system call. Okay, instead it manages its own threads. Okay, the idea of a user level thread is thus not known to the kernel, okay, so as not to burden an application programmer with the coding of threads. Okay, so thread management is performed through a threads library. This library provides functions to create and terminate threads, to synchronize their activities, and to permit them to make requests to the operating system. Okay, so these functions are linked with an application program while creating an executable file for the program. Okay, and in case of kernel level threads, the identity of a kernel level thread is known to the OS kernel. Okay, a process creates thread is in a manner analogous to the create process call discussed before. Okay, so let us call this the create thread call. One of the parameters of this call is start address of the thread in the code of the creating process. The kernel creates appropriate data structure for the new thread and assigns it an ID. Okay. So the call returns with the ID of the thread. The process creating the thread can use this ID for synchronization purpose as well. Okay. Multi-threading models are having three types: many to one model, one to one model, and many to many model. Okay. Let us move towards the next slide. Here is an example of many to many thread model. Okay. Here you can see the process 1 threads and process 2 threads are interacting with the kernel space. Okay. Here is another example, many to one. In case of this, the process 1 and process 2 is interacting with the kernel space, and 1 to 1. Here you can see process 1 is interacting solely with the kernel space, and process 2 is interacting with the kernel interacting with the kernel space solely. Okay. So here we have seen the process scheduling and the kernel, how the thread works. Okay. So thank you very much.